last time we talked about continental drift, right? Who was the first person to come up with the theory of continental drift?
Alfred Wegener.
Alfred Wegener, good. And what did he say? Like, what was this theory of continental drift that he proposed? Magma convection currents. Okay, drive it, but that's not actually the theory that he proposed.
What it all together and then they
yes, so he said that there was this one big giant supercontinent called Pangaea that split apart and the continents are moving, right? Okay, he was laughed at, said he was stupid, and then we proved him right, okay? And so we found a force that is great enough to drive the movements of the continents, and what was that force?
Plates.
The magma convection currents. Move the plates, yeah. Okay, and what's a magma convection current?
It's like when it goes up and then goes down.
Yes, and what drives
Hot
the
goes up and cold goes down.
yes.
Subduction.
Okay. Almost there. So, the differences in the temperature changes the differences in the density of the magma, right, which drives those magma convection currents. So it gets hotter, rises up to the surface because it's less dense, cools off, becomes more dense, settles back down, right? Okay, and then where do those magma convection currents break through the surface of the crust? It's part of the mantle. Mid-ocean ridges. Good, okay? And so breaks through at the mid-ocean ridge and it pushes the two plates apart, right? And then you form your seafloor, breaks through, pushes the two plates apart, form your seafloor, you get this process, okay? This continuous process. That is called seafloor spreading, okay? The Earth is not getting bigger, even though we're creating more crust. Where does it get destroyed?
When it goes down, subduction zone.
Subduction zones. Okay, subduction zones. That's where it gets destroyed. Okay, and then we watched our little video last time. So, okay, here is our evidence that we came up with to prove Alfred Wegener correct in this theory of continental drift. So the first major piece of evidence is that it's true. The continents do look like they fit together. Right? South America looks like it fits into Africa. And it does. Okay? So it looks like they all fit together. The epicenters of earthquakes. Okay? When two giant pieces of rock come together, they don't just slide past each other very nice and easily. Okay? They have problems. Okay? So when two pieces of rock come together, they get stuck. Okay, and so you've got at your subduction zone, your two big plates coming together, and then you've got your spreading centers at the mid-ocean ridge. And the mid-ocean ridge continues to do seafloor spreading, and if these two plates are stuck, okay, this plate is getting pushed down, because seafloor spreading is still occurring, and this pressure is building up, right? Because it's stuck. Eventually, that pressure has to be released, and this plate slides past the other one quickly, and you create an earthquake. Okay, so if we look at the epicenters of earthquakes, okay, and we plot where those are, we can get the outline of the plates, which leads us to the theory of continental drift. Does that make sense? Okay, so the epicenters of earthquakes. If you look at the seafloor temperatures, they are higher near the ridges and then cooler as you move out. It makes sense, right? It's going to be probably pretty hot at volcanoes, and then as you move away from the volcanoes, it gets cooler. Funny. So the temperatures change. The age changes. So as you move away from the mid-ocean ridge, you go from younger rock that was just created to older rock. All right? So the age of the crust changes as well. So all of those things lead us and give us evidence for the theory of continental drift. Make sense? Okay. Here's a picture of Alfred Wegener's Pangaea again. And then this picture is the location of earthquakes and also volcanoes. And then, did we talk about how volcanoes form in this class? Kind of? We watched the video there, right? Mm-hmm. Okay, so here's what happens. You've got your plates, right? Rock at the bottom, and they're covered in water. And there's all sorts of things that live in that water, okay? And those things that live die, okay? And when they die, some pieces of them that can't be dissolved fall to the bottom. And as the plates move, those pieces get carried along with the plates, okay? At a subduction zone where one of those plates slips under the other, those pieces get carried into the mantle, okay, where they get heated up. And they have all those pieces of dead things, they have a bunch of gas and stuff in them. So when it gets heated up in the mantle, that gas gets hot, expands, and rises back through the crust in the form of a volcano.
So the volcanoes are formed by dead fish.
Kind of, yeah.
Really?
Yeah, it's kind of cool. Certain volcanoes, like the ones at the edges of the subduction zones, yes. There's other ones like the hot spots like Hawaii. Hawaii is not formed by that. It's just a hot spot in the mantle. Yeah. So that's different. Yeah, it's kind of weird, right? So this is also the outline of the volcanoes and the epicenters of the earthquakes. Okay, and so here on the west coast of the United States, that we have a bunch of volcanoes and stuff and earthquakes, right? And then over here, there are lots of volcanoes and earthquakes. And basically, this is the Pacific Plate, and you've got a subduction zone on either side of the Pacific Plate. Okay, and then here, notice this. Okay, this is the mid-ocean ridge. That's all the volcanoes, and so this plate is getting pushed away this way, so it's moving this way, and then these are being subducted, so we're slowly moving this way, away from Europe. Make sense? Okay, so take a look at this, and then look at this picture. So this is the outline of the plates. Here's our volcanoes and our earthquake epicenters. What do you notice?
Ring of fire.
The ring of fire. Yeah, basically, like, we took the epicenters of earthquakes and volcanoes, and we came up with our map of what we think the plates look like. All right? Because if you look at the Pacific Plate, right here, okay, so here's our outline of the Pacific Plate. Okay. And then look at this picture here. It's like the same. That's where we came up with what we think the plates look like. Right? So the theory of continental drift led to the theory of plate tectonics, the theory that the Earth's crust is broken into pieces, because it has to be if the continents are going to be moving, right? So the Earth's crust has to be broken into pieces that can move in order for continents to move. Because if the Earth's crust is not broken into pieces, it would be one solid piece and the continents can move. So the theory of continental drift led to our theory of plate tectonics. All right? When you have big plates of crust on the Earth, those plates meet, and you have different kinds of boundaries or borders between the plates. So you can have divergent boundaries, like at the mid-ocean ridge where two plates are moving away from each other, they diverge. Okay. You can have convergent boundaries where two plates are moving towards each other, they converge, like a subduction zone, okay, where one plate slips under the other. You can also have what's called a fault. That's where regions where the plates just move past each other. So if you have like two pieces of continental crust that come together, one's not going to slip under the other, they'll just like slide past each other. Right? So that's called a fault. They just slide past each other. And a rift zone is where it's not at the mid-ocean ridge, but it's where the two plates are moving apart from each other. So you do have a rift valley in Africa that's forming, and the valley's getting bigger. And as it moves apart, as these two plates move apart, eventually the land will be low enough that it'll be below seawater, and the seawater will come and fill in the valley. Right? So that little like hump on Africa will eventually be kind of like an island, like Madagascar. Eventually, one day. Okay? If we're around that long. So, yeah, we'll have a little island off Africa, and Africa will be smaller. Okay, so these plates, okay, and the movement of the plates and all of this continental drift stuff means that the shape of the ocean basins changes over time. Okay, and that's really what we're concerned with, is this is marine biology, right? So we're concerned with the way that the basins of the ocean change over time. So the Atlantic is currently getting bigger, okay, and the Pacific is currently getting smaller as we move slowly away from Europe and towards Asia. All right. So here's again Pangea, right? And you can see here's the Pacific. Okay, so the Pacific is, used to be like one big ocean, right? And then in between South America and North America and Asia and Africa, that's where the Atlantic's going to form, and did form. And then up here at the North Pole, you have the Arctic. So Asia broke off and moved over here, and we have this Arctic Ocean up at the top. Yeah? Make sense? Okay. All right. So currently we have 4 major ocean basins. We have the Pacific, which is the biggest. Okay. And the deepest. The deepest spot in the ocean is found in the Pacific Ocean. So it's found over by Japan. Okay, the Atlantic is the second largest, and it's getting bigger. The Indian is pretty much the same size as the Atlantic, but it's just slightly smaller. And then the Arctic is the smallest, it's the shallowest, and it's the coldest. It's pretty much covered in ice for most of the year. Okay. So there's actually a key difference between the Arctic and Antarctic. So if you go to the North Pole, okay, where Santa lives, okay, if you go to the North Pole, there's actually no land under that ice. It is an ocean. Okay, if you go to Antarctica, South Pole, and you drill through all the ice and the snow, you would find land. Antarctica is a continent. Okay, whereas the Arctic is just simply a ocean. Just water. Right, so Santa lives on ice. There's no land under there. Okay. The Pacific, the Atlantic, and the Indian Ocean all meet around the Antarctica. Okay? You got North Pole, South Pole, and then you've got like the Pacific, the Atlantic, and the Indian Ocean. And they all come together and they all meet at the bottom. So that last number 5 on your notes should be the Antarctic or Southern Ocean. Okay? So all 3 of those oceans meet in and around Antarctica in what we call the Southern Ocean. Alright? That means that water from the Pacific is connected to water from the Atlantic and the Indian Ocean around Antarctica. Right? So that means that water from the Pacific Ocean can move through the Southern Ocean into the Atlantic and then through Southern Ocean into the Indian. So this happens. We actually have worldwide currents where water will be moving from one ocean basin to the other. Okay? And it's actually super important in maintaining the climate on Earth, which is kind of cool. So we have whole ocean currents because they're connected at the Southern Ocean. Kind of cool. All right, so here's a picture. Here's the Pacific, the Atlantic, and then the Indian Ocean is right here. Okay, and they're all connected down around here. Okay, seas. And seas are located at the edges of ocean basins. They're smaller. Okay, and there's lots of different kinds. So if you see, have ever heard of like the Gulf of Mexico? That's a sea. Okay, the Gulf of California, the Red Sea, Persian Gulf, Caribbean Sea, Mediterranean Sea, all sorts of different ones. All right. So again, edges of the ocean basins. Smaller, itty bitty living space. Okay. In the sea. Okay, this picture is kind of funky, but it's to help you see the Southern Ocean. So normally, if you have your globe, right, when we take it and we make a map, we flatten it like this way, right? And you look at it like straight on. This picture, if you take that globe and then you flatten it this way, that's what we did. Okay, so it looks kind of funky. But this is the North Pole right here, okay? And then this is the South Pole right here. Okay, so this is Antarctica, here's the Arctic Ocean, okay? And so, here we are right here. Here we are. Okay, so this is the West Coast, okay? This is the East Coast. So here's the Pacific Ocean, the Atlantic, okay? And then Asia and part of Africa and Australia. And then over here is the Indian Ocean, okay? So you can see easily, hopefully, how the Indian Ocean, Atlantic, and Pacific all come together right around here. So water can go doo-doo-doo, like all the way around through all the ocean basins. Okay. So that's like what ocean basins are and what the seas are, and now we can look at some different features that you'll find on the seafloor. Okay, so let's look at that. One of the major features that you'll find into the ocean is what we call the continental margins. Okay, and continental margins are the edges of the continent that stick into the water. Okay, and you can actually like experience this because if you go to the beach and you like stand at the edge of the water and then you decide you're going to walk into the water, you walk into the water, right? And then going and eventually like you're walking on land and eventually you have to start to swim, right? So you get too deep. Well, the land that you're actually walking out on into the ocean is what we call the continental shelf. Basically the continuation of the land into the ocean. Okay, so let's draw a picture, and I would suggest that you draw a picture, and we're going to add to this with the next few slides, so maybe like turn your paper sideways and draw it on the side of your paper, because you will have to notice. So here's the water, okay, and then here's our continental shelf. So let's say this is you, here's a palm tree that you're sitting under, okay, you're on land, okay, and then as you walk into the water, this continuation of land into the water is the continental shelf. So this is the shelf. So you've got continuation of land as the continental shelf. At a certain point, you get a drop off, right? So where this land just kind of like plummets downwards. Okay. The point at which that happens, okay, where it changes from this kind of gentle slope of the continental shelf to a very steep slope, that's called the shelf break. All right. So the continental shelf break. On average, worldwide, your continental shelf is about 40 miles wide. Okay, so when you go out into the water, you're still over what we consider the continental shelf for about 40 miles into the water. Okay, that's on average worldwide. That's not like our coast is a little bit different from the East Coast. Okay, so it varies, but on average, it's 40 miles wide. And then this break occurs at about 200 meters depth, so 200 meters deep in the water. There you go, 200 meters. That's about 660 feet. Okay, so 40 miles out, 660 feet down, it drops off. Okay? And then you get what we call the continental slope. Okay? That is the steep slope that goes all the way to the bottom, to the beach. Okay? At the bottom of the slope, we have this thing called the continental rise. And basically, what happens is like all the dirt and the sand that's up here on the continental shelf, if it makes it here to the break and gets like pushed over the break and runs down the continental slope, it all runs down, okay, and then it hits like the sea floor. So if it runs down at this angle, okay, if you have sand that runs down, is that going to like spread out on the bottom, or is it just going to like accumulate right there at the bottom where the two? Yeah, it's going to pile up. Okay, that's exactly what happens, and we know that is the continental rise. Okay, where all that dirt and stuff piles up at the bottom of the continental slope. It's called the continental rise. After this, after the rise, that is considered to be the end of the continent. Okay, no more continent. Now we have what's like seafloor. All right. So if I were to ask you on a quiz or a test or something like that, what are the 4 things that make up the continental margin? The end of the continent?
Shelf, break, slope, and rise.
Excellent. Alright, shelf, break, slope, and rise. You will have to know. So, that's the end of the continent. When we get to seafloor, most of the seafloor is what we call the abyssal plain. Okay? So the abyssal plain makes up most of the seafloor, and if you think of the abyssal plain, think of it as like this big flat stuff at the bottom of the ocean. So if you've ever been to the Midwest, to Iowa or something like that, it's weird because here you look around, you'll see mountains and stuff. You go to the Midwest, you stand there and you like look around and it's just flat. There's no mountains anywhere. Okay, that's like the abyssal plain, flat. Okay, and most of the ocean floor is an abyssal plain. Okay, so here's our abyssal plain, big flat part. You also have the mid-ocean ridge. Okay, I'm going to draw it kind of like this to represent a volcano, and abbreviate it as MOR. Okay, mid-ocean ridge. That's the underwater mountain range where seafloor spreading happens, where new seafloor is created. Edges of the plates. Right, runs all the way around the world. Largest geological feature on Earth. You good? Yes. Okay. There's some other features that you'll find on the seafloor. Let's relabel some of these. Okay. You can also have things like, they're called islands. They're basically volcanoes that have erupted enough and have created enough land that land breaks the surface of the water. Okay, Hawaii is an island, right? And it's still an active volcano. So you can go and you can see the volcano erupting, the lava running into the water, right? So it's created when a volcano gets big enough to break the surface of the water. Okay. You can also have seamounts. Okay, seamounts are islands, or basically volcanoes that haven't broken the surface. Okay, and so they're called a seamount. They are mountains underwater. And then you've got trenches. So that's my trench right there. Okay, and trenches are the deepest spots in the ocean. They occur at subduction zones, where one plate's forced under the other.
What's it called?
A subduction zone or a trench. Okay? So those are some different features that you'll find. And the reason why this is important is because a lot of the things that we talk about, like some of the different ecosystems, like coral reefs and kelp forests and stuff, are found like on the continental shelf, okay, and in certain areas on the continental shelf. Whereas like seamounts are important because they cause nutrient-rich water to come up and create a nutrient-rich spot for a bunch of life to live. Okay. Mid-ocean ridges are important because there's hydrothermal vents, and those are their own special ecosystem in and of themselves. So all of these features have different things about them that allow for there to be different ecosystems, which means different animals. It's kind of cool. All right. So you have two types of margins. Okay. You have active and passive margins. Okay. Active margins are where you have one plate slipping under the other, so they occur at subduction zones. So like the west coast is an active margin, where you have one plate slipping under the other. And so when you have that, you have a very, very like narrow continental shelf and a very steep slope and no rise at the bottom because it's a subduction zone, so there's a trench. Okay. A passive margin is the edges of the continents where the two continents broke apart, and so it's got a very, very wide continental shelf, very gentle slope, and a very well-developed rise at the end. Okay. So let me kind of draw you a picture, help you see this. Okay. So for an active margin, you're going to have like a very steep and narrow continental shelf, very steep slope, going to go down and end in a trench. Okay. this is California. So when we go out into the water, like at the beach, you don't go out very far before you're treading water, right? And that's because, like, you go out and this continental shelf is a fairly steep slope. East Coast, okay? It's a very wide continental shelf, okay? And then a very gentle slope and a very well-developed rise at the bottom. So if you go swimming in the water of the Atlantic on the East Coast, it's weird because you can like walk out really far into the water and not be very deep. Like you walk out and you're like from California, oh, like I'm not very far in or far out because the water's only up to my knees, and you look back and you're like hundreds of yards from the shore. It's weird. It's very strange. So and you can go like sometimes half a mile out and you're only like up to your waist. It's so weird. So that's because the West Coast is an active margin, subduction zone. East Coast is a passive margin. Okay. Here's some terms that you're going to hear forever in this class, many times. So make sure that you know what these mean. Here they are. Pelagic. Pelagic means in the water column. Okay? So here's our continental shelf, right? And then break and slope. And then here's our water. Okay, here's our water. All here. So anywhere in the water column, we call that pelagic. And you'll hear that in terms of like, there are pelagic organisms. So animals that live in the water column. Okay? Or pelagic ecosystems that are entirely in the water column. Okay? So pelagic water column. Benthic means bottom. Okay? Benthic bottom. So benthic means anywhere on the sea floor. Okay? Whether it's like deep in the trenches, on the abyssal plain, or on the continental shelf. Benthic is bottom. Right? And then you've got the intertidal zone. That's the place on land that gets covered and uncovered by the tides every day. Right? Make sure you know those. Okay. So if you go to the seafloor, we've been talking about all of these plates and stuff. If you go to the seafloor, you're not just going to like land and hit rock. Okay? That rock is covered by sediment. Okay? All of that stuff that's in the water column that settles out of the water and lands on the bottom. Okay? And because scientists are nerds, we actually classify that sediment according to size. So we take pieces of dirt and we look at the size and we say, oh, because it's this size, we're going to call it clay. Or if it's this size, we're going to call it sand. Okay? So, yeah. So we've basically taken and said that anything that's 0.062 to 2 millimeters, we're going to call that sand. Okay? Anything that's bigger than 10 inches, it's a boulder. Okay? So, I know. But all of this stuff, okay, clay, silt, sand, all of this is on the seafloor. Okay? And we have 4 major types of sediment that you will find. We have hydrogenous sediment, biogenous sediment, aerogenous sediment, and cosmogenous. Okay? Hydrogenous sediment, basically you have water and you have chemicals in water. And chemicals react. And when chemicals react, sometimes you form precipitates. And those precipitates fall out of the water to the bottom and form hydrogenous sediment. Okay? Diogenous sediment is formed by living things. So you have things that are living in the ocean, and when they die, their soft tissues get dissolved, decay, decomposed. Some of them have shells and stuff like that. Those do not get broken down. Okay? They fall out of the water to the bottom, and they form biogenous sediment. Okay? And some of these things are like tiny, tiny microscopic plankton shells, okay, that you'll find. So they're teeny, teeny, tiny. So this is like what it would look like if you look at it under a microscope. Okay, so like there's teeny, tiny little like snail shells at the bottom of the ocean. These are like radiolarians, which are like teeny, teeny, tiny little plankton. They've got little shells. Okay, all of that stuff falls to the bottom. This is a copepod. We'll learn a lot about these. They're like crabs. They've got a hard shell, like a hard outer covering, that doesn't break down in water. So when they die, those little pieces fall to the bottom, form sediment. They're like, you'll see, they're like microscopic. They're small. So you'll look at them under a microscope. Terrigenous sediment is produced by the weathering of rocks on land that then get carried by rivers and streams into the ocean and settle on the seafloor. Okay, so it's dirt on the bottom of the ocean. And cosmogenous, when you get meteors that come through the atmosphere protects us and burns up those meteors. But those particles of the burned up meteor are in the atmosphere, fall out into the water, are heavy, and fall to the bottom. And so we have pieces of outer space on the ocean floor. Kind of cool. So sediment made out of four things. Okay? Precipitates from chemical reactions in water, living things, dirt from erosion of rocks and stuff on land, and pieces of outer space. All of those on the bottom.
Foundation